here we are asked to find the vector AB. Now, there's no specific formula in the IB data booklet that can help you with this, but you should be able to find it out from first principles using vector knowledge. So if we have two points in space, so here's 3, 2, oops, and over here is 1, 5, 3. Then these coordinates are from the origin. So this is the origin, and that is their equation. That is their coordinates from the origin. So this is A, and this is B. It doesn't actually matter where they are. And AB will be the vector from A to B. And what is the resultant of A? Well, if you know from basic tip-to-tail vectors, the resultant vector will be equal to this, this to this. So if this is A and this is B, that's the resultant vector. So if you have two vectors and you want to add them, you just add them to tail and whatever, and then you go start to finish, and that's your resultant vector. So in this case, how do we find AB? Well, we need to go from tip to tail. But you see how, so this one B is already in the right direction, but A is not. A we need to flip to make it backwards. So actually the vector AB will be equal to B, OB, minus OA, because OA needs to be flipped, so in that sense, so that way we'll have a tip-to-tail vector model to find AB. So this is generally memorized, but this is the derivation and logic from it. And then we can just do the calculation. 153 minus 321 equals minus 232. So that's the equation of AB. Now to write down a vector equation of the line in the form r equals a plus tb. A vector equation allows us to account for many points on a specific line. So it'll take a line. With a vector equation, you should be able to describe the points on a line just through the vector equation. And how it does that is that it says it takes a point A, the initial starting value, and then it adds on TB, this factor, which is a factor which, if you have a certain amount of time or x value, then you should be able to add B, which is the scaling vector, onto A, and then get a new vector. So you might have that might be T, that might be T2. Oh god. That might be T3. And as you add T, which is also just another vector, to A, then you'll be able to describe all of the points on this line. So in our case, R equals A plus TB. We can just pick either A or B. It doesn't really matter. Let's just pick A, be consistent. T, that we don't change that. That is just something that the person using the equation will use. And we see that a line L passes through these points. So there's actually a line going through here, right? And what the multiple vector is, well, that's just AB. That's what we already found. So that'll just be times AB, which is minus 232, and that's the answer.